Three, two, one. Welcome to the latest episode of the Uncited podcast. I am Diana.
Hi, I'm Natasha.
Long time no see, and today we are here with a very, very hot topic, the COVID vaccine.
Woohoo!
Yeah. So, in the past few weeks, we've had quite a lot of announcements from various pharmaceutical companies that have come up with viable vaccine candidates.
Uh-huh.
So that's promising. That took our mind off from the election for a while, at least. And yeah, it's been a year though,
Yeah,
I want to
11
say,
months. Yeah, feels like a year.
and it's been a rocky year in general, 2020. But today we're gonna look at the vaccine candidates. We're gonna look at the promises those pharmaceutical companies make. What is a vaccine? How does it work? And also, what would be a potential timeline maybe for all of this?
Yeah, realistic timeline for it to be available to all of us.
Mm-hmm.
So, yeah, I still remember last year around this time, we all were counting down to ring in 2020, and little did we know what was
Oh,
awaiting
yeah.
ahead of us. And while COVID continues to rage, we
Mm-hmm.
might see an end to it soon, hopefully. So let's begin with the two biopharmaceutical giants, Pfizer and Moderna, who have
Mm-hmm.
announced their vaccine candidates, which are nearly 95% effective, which is, by the way, high for a vaccine
It's
candidate.
super high. Like when I first heard that, I was like, what, really? Because we know that the flu shot is like, what, 70% at best
Yeah.
effective.
In fact, for FDA to approve a vaccine candidate, it has to be at least 50% effective. So you can imagine
That's a
how
low threshold.
true.
Not setting the bar too high there, huh?
Mm-hmm. And hopefully it will be available in a few months. But until then, we must continue to take all the necessary precautions. Remember the three W's: wear a mask, wait 6 feet apart, and wash your hands.
www.
World Wide Web.
So one thing that people ask is, wow, that was quick, right? For the
Mm-hmm.
development of a vaccine. Like, how do you feel about that?
Yeah. What's noteworthy is that while vaccine development typically takes decades, I'm not exaggerating here.
Mm-hmm.
So these candidates were developed in a record-breaking time of only 11 months. For reference, the chickenpox vaccine took 28 years to develop. And I think so did the influenza vaccine. And
And it's still being researched upon, like the flu vaccine. It's
yes,
still being perfected after all those decades. It's
because
crazy.
every flu season we have like a new strain because of the
Yeah.
mutations, so they have to develop one almost every year. And the big question is how is it possible for these companies to manufacture a vaccine in such a record time?
Yeah. First of all, let's help our listeners because I know some of you might be experts in the field, but some of you might not have such a good grasp on what is a vaccine and how does like a vaccine work in general.
Hmm. So let's take a step back. So traditionally, vaccines were made using weakened viruses. So these viruses are incapacitated, meaning that they are not infectious anymore. So they basically could be some component of the virus, which by
Mhm.
itself cannot cause any infection.
Viruses, I think they blast them with either radiation, antibiotics, and in some way they render them less dangerous.
Yes. And because they are foreign, they cause immune activation when injected into the body. It not only alerts the immune system but also trains it to take care of any future reinfections.
Mhm.
So,
Oh, it's interesting though, because viruses have actually been around for quite a long time. It's
yeah.
the first mention. Sorry, I said viruses. I meant vaccines. Duh. The first mention historically of a vaccine is actually around 1000.
Oh,
like the year 1000 from the
common
Chinese.
era.
Yeah, they were experimenting with some form of injecting weakened viruses or people who got sick with a virus but did not exhibit the symptoms as much. So they had kind of a grasp of what's happening. But the first, I want to say, more scientific de- development and trial of a vaccine was actually performed in 1796 by Edward Jenner,
Mm-hmm.
and that was smallpox era,
Right.
and smallpox was raging all around the globe. So what he was basically he made the observation that women who were milking cows sometimes had those rashes on their hands, and they had contracted a form of the virus that was known as cowpox because it was like smallpox that but you get it from cows. And the women who had this cowpox and those rashes were actually immune to smallpox.
Mm-hmm.
So what he did is he literally directly took some fluid from those rashes and he injected it to young patients, and they did develop an immunity. I mean, I don't know what his efficacy was. I'm sure he accidentally might have killed a lot of people because this was 1796 people. But yeah, it's
I think this was the first recorded instance of immunization.
yeah, in like a more proper scientific way. But another question we all have is, okay, so you get the vaccine, whatever. What's happening to your immune system after that? And I think you're the most qualified to explain this because of your background.
Yeah, I love immunology. So, the way that vaccines work and the reason why it's able to work is because of a phenomenon called immunological memory. It's the ability of the immune system to recognize a previously encountered pathogen. And there are two types of immune cells that regulate immunological memory. They're called B cells and T cells. So, B cells are special in that instead of participating in direct combat with the pathogen, they engage helpers known as antibodies, which you probably have heard of.
Mm-hmm.
And these are Y shaped proteins targeted against the pathogen. If you have ever played laser tags, these antibodies are analogous to the laser lights that tags the target for elimination.
Oh, okay, that's an interesting analogy. Never thought.
I
Okay.
just came up with it in the morning.
I just think about it as Legos or something, you know, but
Yeah,
only
that is,
one piece specifically fits to the specific virus and other ones don't fit, and it's a whole.
yeah, it fits perfectly, and that's how you
Mm-hmm.
recognize. You have to engage the receptor and the protein. So once the antibody binds to the antigen, like a Lego piece, it signals T cells to execute the invader. So T cells are essentially quote unquote executioners. It's important to note that not all B cells and T cells participate in an immune response. We have naive B cells that when encounters a pathogen, it divides to form two kinds of cells. One is called the memory cell and one
Mm-hmm.
is the effector. And the effector cells are the ones that execute, and the memory cells, they just hold off for now and they basically act in the future to ward off reinfections and subsequent encounters. And what's interesting about these memory cells is that they are long living cells, which is important.
Yeah, because you want to be protected from whatever virus, basically, if possible, for the rest of your life.
Hmm. Yes.
But sometimes some vaccines do have to be performed in multiple doses, or your
Yes.
doctor will tell you have to repeat a vaccine every 10 years. And that is basically from what you're saying, because the memory cells have
Yes.
that sort of lifespan
That's right.
in your body.
I think I came across a study which reported memory cells for COVID-19, and it had like a lifespan of about 6 to 12 months.
Mm.
Yeah, but it's not a peer-reviewed study yet, but
Yeah,
that's
and also like
promising.
I don't know, because 3 months ago they were telling us it's only like 4 weeks, and I was like, why?
Yeah, and depending on how strong or depending on the kind of virus, you might, like Diana suggested, need subsequent doses, shots, I mean. So it's the second shot is known as the booster dose.
Hmm.
It boosts the immune system. So it's going to be a stronger response with every subsequent encounter.
And in my mind, I'm more likely to put the COVID vaccine in the flu vaccine category, and we do have to repeat the flu vaccine every year. Actually, it's
Hmm.
recommended that you repeat it every 6 months.
Yeah, it's because of the new strains that are coming up.
Yeah, so that might be something that we will see in the future,
Yeah.
if even if we get this vaccine working, if the virus mutates, we might need to refresh
Mm-hmm.
our vaccines every now and then.